Hey there, y'all. Today we're going to look at 1.8. We're going to finish off the second half of this lesson on optimization with linear programming. We're still looking at being able to solve real-world optimization problems using linear programming. We talked about the max and mins of the functions in the first video of this. And so the standard we're looking at as we close this out, ACE.3, being able to use those systems of inequalities to represent constraints in a real-world situation and solve such systems using graphical and analytical methods, including linear programming and interpreting those solutions within the context of the situation. So we previously talked about bounded regions, and we previously talked about unbounded regions, and now we're going to apply those to dealing with linear programming. And so these are the 6 steps that it takes to deal with optimization, particularly in a word problem. First, define the variables and write the system of inequalities. And so as we look through the word problem, we're going to pick out the information that we need and we'll write our system. Step 2, graph the system. Step 3, find the coordinates of the vertices of the feasible region. Step 4, find a linear function to be maximized or minimized. Sometimes this is given to you immediately, sometimes this is a part of the word problem. Step 5, substitute the coordinates of the vertices into the function. And step 6, select the greatest or least result as required. So if we're trying to maximize something, we want the largest. If we want the least, then we're going to look for the minimum. All right, so let's look at how this works in a word problem. So the example is this. A landscaping company has crews who mow lawns and prune shrubbery. The company schedules 1 hour for mowing jobs and 3 hours for pruning jobs. Each crew is scheduled for no more than 2 pruning jobs each day, and each crew's schedule is set up for a maximum of 9 hours per day. On the average, the charge for mowing a lawn is $40, and the charge for pruning shrubbery is $120. Find a combination of mowing lawns and pruning shrubs that will maximize the income the company receives per day from one of its crews. So let's review the steps. Step 1 says to define the variables and write the system of inequalities. And so when we look at this problem, our first variable in the problem is mowing jobs. And so M will be the number of mowing jobs. And P will be the number of pruning jobs. Now, we need to write the system, and we need to understand what information is going to come out of here. And so what are we trying to do here? We've got time involved and we've got cost involved. And so the cost is what we're trying to maximize. So that's going to be our function in the end. And so that'll be the function that we build. So what we're trying to deal with is how many mowing jobs and how many pruning jobs I can deal with. And so let's look at what those will be as we write this system. So we're told that each mowing job is 1 hour. And we're told that each pruning job is 3 hours. Okay? And they can work for a total of what? 9 hours per day. So as we build that up, we're going to get 1M plus 3P, maximum here, has to be less than or equal to 9. Because again, our mowing jobs are an hour each, the pruning jobs are 3 hours each, and so whatever combination of mowing and pruning that I do, that's what's going to come out to our time. Okay? The second part here is this next sentence. It says that each crew is scheduled for no more than 2 pruning jobs per day. And so we have a second restriction here that P, the number of pruning jobs that I do, must be less than or equal to 2. And so those are the 2 inequalities we're going to deal with in this situation. Now, obviously, we are restricted to the first quadrant, and so 2 other constraints that we would have here is that M, of course, has to be greater than or equal to 0, and P has to be greater than or equal to 0. And so let's see what that graph is going to look like, because that is step 2. What is our graph? So as you see here, I've graphed up the inequalities that we have. And so just to give you an idea of which one's which, this one coming here is the 1M plus 3P is less than or equal to 9. The horizontal one here is the P is less than or equal to 2. And you also see that I have that m is greater than or equal to 0 and p is greater than or equal to 0. So where do all these overlap? It's going to be the darkest shading that we have, and so it creates this trapezoidal figure here. And as we talked in the first half of this lesson, we talked about where the maximums or minimums can happen. And so we want to look at the vertices. And so I've got 1, 2, 3, 4 vertices to deal with. And so we want to label all those out. And so I've got 0, 0, 0, 2. This is 3, 2. And then over here is 9, 0. And like we did before, our next step is to deal with our function, right? So we're going to set up our table and have some function here, f of mp. But we haven't written our function yet, so let's go back to the word problem. When we look at this word problem, it says on average, the charge for mowing a lawn is $40, and the charge for pruning shrubbery is $120. So this is what's going to build our function. F of mp is equal to what? Well, for each lawn they mow, it is $40, so 40 times m. And then for each pruning job, 120 times p. Now, that's what we're going to put here. And so we're going to try it for each one, figure out which is our max, because that's what we're trying to get here, right? We're trying to maximize the income. I don't care about the minimum in this problem, okay? And so we plug it in for each. So 0 plus 120 times the 0, that is going to give me 0, because 0 plus 0 is 0. And then here I've got 40 times the 0 plus 120 times the 2, so it's going to be 240. Here I've got 40 times the 3 and 120 times the 2. So 40 times 3 is 120. This is 240, so it gives me a total of 360. And then finally here, 40 times the 9 plus 120 times the 0, that'll also give me 360. And so again, I'm looking for the maximums. So where's my maximum? I actually have 2 here that I could do what? Well, remember that the first is m and the second is p. So I could do 3 mowing jobs and 2 pruning jobs to earn how much? $360. But I could also do 9 mowing jobs and no pruning jobs to earn $360. So in this problem, we see that this actually has 2 maximums that we can work with here. And remember, maximums and minimums will only occur where? At our vertices. And so either one of these 2 answers is acceptable for the final answer. You don't necessarily have to find both, but you do need one or the other. Now, what would change this problem? Let's just talk hypothetical for a second. What would change this problem? Well, a couple things could change it, right? Let's say there's no restriction on the pruning jobs, right? So that would change this line, and I would not have a maximum occurring here anymore. Or I could change how much pruning jobs and mowing jobs are. Maybe mowing jobs are worth $50 each, and pruning shrubbery is $125. That would change where our max would occur. And so, again, that is a possibility in these problems. Okay, so that's it for today. That ends this unit on Unit 1 on linear functions. And so we are going to be preparing for the unit test. So be looking out for the unit review video and then be preparing for your test. And I hope you all have a good one and see you next time.